Welcome to SciTech Culture with Steve Kern and Ben Warner, where we examine science, technology and culture in the 21st century. Visit our website at scitechculture.com. Hello and welcome to SciTech Culture, the show where we discuss science, technology and culture in its myriad of forms. My name's Ben Warner and I'm joined by my good friend and colleague Steve Kern. How are we today, Steve?
I'm good, thanks, Ben. Looking forward to our discussion today on some of the big questions in physics.
Yeah, absolutely. And there was an article on the ABC about CERN and the Large Hadron Collider. And it's interesting on the internet. There's some stories around this. It's like, what have you done for me lately, kind of thing. The Higgs-Boson was like so 2012. That was. It's almost like people have moved on from the fact that that was such an amazing discovery. Oh yeah, we found it now. No, it's not a big deal anymore. So let's see what else is out there now. As we were just saying before we got on the show, a lot of what we're going to talk about now, I was thinking of Star Trek: The Next Generation, and I just watched the final episode, All Good Things, a couple of days ago, in which they spoke about a anti-time eruption where they were cancelling each other out, and it's actually my favourite episode of the whole show, and I believe for a lot of people who are fans of the show. But looking at this story about the LHC, and some of the things we'll talk about, it kind of brought up memories of that show. And I mean, we don't see a lot of it being shown today in Hollywood or on in television, and that show really did show off a lot of these concepts, regardless of whether or not how accurate they were. But the fact that they did it so convincingly was impressive.
Yeah, look, I think Star Trek and certainly Next Gen has been really underrated for, I guess, a lot of the thinking that it's brought to contemporary culture, although people seem to consider that Trekkies aren't contemporary people, but
yeah,
there you go. But there have been other shows as well. The British show Red Dwarf has been fantastic. And even when Douglas Adams was writing for Doctor Who during the Tom Baker era, there have been a lot of high-level science or I guess, particle physics ideas that we're investigating at the LHC now, brought into popular culture.
Yeah, exactly. All right, let's move on to what was discussed in this article. And basically they had, say, the top 5 things that they could be looking for, and maybe the LHC can provide some answers. The first one they've got on the list here is dark matter, saying that it makes up 75% of all the matter in the universe, but scientists still don't know what it is, which is why they call it dark matter. Astronomers first noticed that dark matter was there when they realized that there wasn't sufficient gravitational attraction to keep stars orbiting as fast as they do around the galactic center. Would it be, I mean, this sounds like it'd be something very hard to find, but given the nature of the project at CERN and with the LHC as an instrument, do you think it's possible they could find something there?
Well, yeah. I mean, the reason it's called dark is because they can't see it. The calculations show it has to be there.
Yeah.
To achieve the universe that we see or observe.
So in a sense, that's a bit like the Higgs-Boson as well, isn't it? They calculated that it was there, but it was just a question of how to find it physically or whatever, where they could actually see it.
That's right. And so what they'll do with the LHC is try to create some dark matter particles or evidence that dark matter particles are there through some sort of other particle interaction. That's about as simply as I can put it.
Well, it's quite interesting. For most people, and myself included, would think that when you go and try and find something, you're literally trying to find it and see it. There's a lot of this sort of thing where it can become a bit, maybe it can become a bit hard to understand, is that they can probably prove that something exists based on the fact that it's reacting against something else, even though they can't see it.
That's
sort of
right.
thing.
So that's precisely how they go out and do it. And I guess this is where it's very hard for us in our everyday lives to understand what they're actually doing. So they have a set of equations, and that gives us a standard particle models. We don't need to understand them, but to appreciate the fact that the patterns show that they must all exist.
Yeah.
And by looking at certain areas of that particle, the ways particles interact, you can predict the fact that the other particles must be there, even if you can't see them.
Yeah, exactly. All right, let's move on to the second one. And again, channeling Star Trek here with antimatter. Basically here they're saying antimatter is the same as normal matter, but with an opposite charge.
Yep.
Scientists believe equal amounts of matter and antimatter were made in the Big Bang, so the two should have annihilated each other almost immediately. But because we exist in a matter world, scientists believe there must be subtle differences in the properties of matter and antimatter. This one sounds like it's a bit more dangerous because, on Star Trek they kept saying, things would explode when these two came together. So, but the interesting thing they said in here was that CERN's already made small quantities of antimatter, and they did an experiment storing 309 atoms of anti-hydrogen, but it disappeared after 17 minutes, they said here. So obviously with a bit more time, they might be able to make that more stable and you have some sort of application for it that way down the track.
Well, I think the obvious use for this technology would be the disintegrator ray, because basically antimatter will cancel out matter. So if you could make an antimatter ray and beam it onto some matter, theoretically it should just disappear.
Oh, so there you go. The Despicable Me scenario comes into play there.
Well, that's it. How far does the ray go, though? If you shoot it into the Earth, does it just make a hole straight through the middle?
gives new meaning to mining and tunneling, doesn't it?
It certainly does, except I don't know how it would work there, because if you were after anything good and you hit it with antimatter, it would disappear.
It would just be gone.
Who knows anyway?
Yeah, exactly. I'm sure they'll find some way to put it to good use at any rate.
Well, I was going to say, it sounds like a fantastic weapon that George Lucas has already thought of, I think. The death ray, I'm not sure.
Yeah, exactly. All right, the third one they've got on the list here, exploring gravity and extra dimensions of space-time. Scientists want to understand why gravity is so different from the other forces of nature. And they think they may be able to test for extra dimensions by looking for particles that can only exist if these extra dimensions are real. Is it they have a theory, perhaps they can calculate it, but it's a question of how they actually find it by using that?
Yep, I'm not going to go into this because I got murdered when I tried to describe the Higgs-Boson back a couple of years ago, but there is an equation that's 400 years old that Newton came up with that's still relevant for this today.
Right.
So it's your usual force, mass, gravity style equation. By, once again, looking at what they're seeing, the results from the LHC, they can plug those results into this old equation.
Okay.
And they can see if there are extra dimensions.
Fantastic.
I'm not going to explain any more than that.
Oh, it's exciting anyway, but because it opens up new possibilities of existence, I guess.
Well, if we see that there are other dimensions, I don't know what that does to our normal thinking, because suddenly all sorts of possibilities open up. Sci-fi becomes sci-reality.
Exactly. And we'll be traveling out in space with our warp engines before you know it.
Well, that's could be well how they work.
Exactly. All right. The fourth one here, creating black holes. Now, I like this one because this is actually feeds into the hysteria that surrounded the creation of the LHC in the first place. That that people was I shouldn't say people. I should say some people were of the impression that as soon as they switched this thing on originally, that it could create, say, a black hole, envelop the Earth, and we'd all get swallowed up and destroyed in an instant. Perhaps that would the LHC is a marvelous machine, but I'm just wondering if that was giving it too much credit, that it could create something that powerful. But they were saying here the LHC hasn't made any microscopic black holes, and if it did, they would be so small they would evaporate very quickly. I won't go into the number they've got here, but it would decay into either normal or supersymmetric particles. So is this sort of a misnomer or just fear-mongering, or what do you think, Steve?
Well, I guess what I think might not align with the science, I don't know. But look, as simply as possible, real black holes are quite large by comparison. So even if you talk about a black hole in space that's the size of my fist, that is more than 1 trillion times larger than a subatomic black hole. So you would expect, while they'll have certain similar characteristics, they're not capable of doing the same things because their actual size difference is magnitudes different. So I think it is quite safe to create these smaller black holes, and it will give us an insight into what happens. And we all talk about, our next-gen stories or Interstellar, where they go through black holes to wormholes, to other dimensions, to other places, time travel. If we're ever going to understand that, if we're ever going to access technology that can create those capacities for us, then we have to understand black holes at the tiniest level. And this is the safest way to do it, because I for one, sure as hell aren't driving out to space to fly into a black hole.
Maybe it's also that these people who were so afraid of death and destruction due to black hole creation were probably thinking that it's a more fanciful science fiction, where they could just press some keys on a panel and on a touch panel, and all of a sudden they've created a black hole the size of a planet.
Well, this comes back to your disintegrator ray kind of thing. Would they use it as a weapon? Is it a conspiracy? Is something going to come out of there?
Who knows?
It's highly unlikely. And I think one of the things that the guys at CERN keep saying is that, they can do the calculations that can predict that it just can't happen.
Yeah, exactly. All right, and finally,
not can't.
Exactly. Yeah,
it could happen. It just won't.
Yes,
they're two very different things.
That's right. And just finally, the fifth one they've got here, which seemed to be the strangest one, or at least the strangest named one, giant killer strangelets. As well as black holes, another theoretical danger of higher powered collisions at the LHC could be something called a killer strangelet, which are hypothetical subatomic lumps of strange matter made up of almost equal numbers of up, down, and strange quarks, which according to theory would get more stable as they grow larger. One theory suggests strangelets should change to ordinary matter within 1,000th millionth of a second, eventually destroying the Earth by turning it into a single giant killer strangelet. This, to me, I'd love to see this in a film, though. But
look, this is interesting only because people fixating on obviously the extreme danger, but it goes both ways. This is purely, I don't know, somebody's conspiratorial thinking that we're going to make a strangelet and it's going to turn the Earth into a giant strangelet and we're all going to die. But no one has an issue on next gen with, let's have a little bit of imaginative play with what happens if we go through a wormhole, or if I, do some teleportation and all those sorts of things. And I think, as one of the scientists at the LHC said, that, if this really was a danger, it would have already have happened. So
yes,
sure, it's possible. Sure, it could happen. But in probability, it's at the really low end of the spectrum of it happening. So we really don't need to worry about these things, and we should actually embrace the fact that this could happen in terms of better understanding what a strangelet is.
Just finally, I wanted to just touch on the philosophical aspect of the LHC, which to me actually took me by surprise, because I just thought that this was a big science project. I mean, I know that's sort of, makes it sound a bit smaller than what it is, but it's another tool to for scientists to explore things and explore the universe, etc. I was quite I don't know if surprised is the right word, but just to see the whole discussion around the philosophical aspect of it, that we shouldn't be messing around with finding out how the universe was made because we could unravel ourselves, or these are questions we don't, we shouldn't need to know the answers to. And this whole sub thing that's sort of played up out of this is quite extraordinary. Well, I mean, it's like saying really man should never have made fire because look what it's done. It's
it's an interesting philosophical question. But I think the interesting thing about the LHC is today the science that's being studied there, to be fair, really has little relevance to ordinary lifestyles and activities. But give it another generation, the science and the learnings from the LHC, people will have a real interest in, because technologies like teleportation, potentially time travel, disintegration rays, uses for antimatter, whatever, will become commonplace. And because we'll be traveling around the universe at some stage. We are not going to live on this planet forever.
So, as Interstellar said, and it's also something to look forward to.
Exactly.
All right, Steve, we might wrap it up there. So thanks again for that. It's a fantastic topic. I love returning to CERN and LHC whenever we can. So hopefully at some point soon they'll have another news story to, surprise the world with.
Well, they're switching it back on soon, so I'm sure we'll have another topic then.
Yeah, absolutely. All right, so don't forget our website, scitechculture.com. You can get all of our links there, and don't forget to subscribe to our channels. That's how you can keep up with all of our latest audio and videos. You can follow us on Twitter, Facebook, and Google+. I'd love to hear from you there. Feel free to open up a discussion. We're always up for that. And if you think anyone's interested in these regular discussions that Steve and I have, feel free to send them to our website. We'd greatly appreciate that. All right, so that's it for this episode. We'll catch you next time.